Okay, thanks for the introduction. We're going to talk about migrating Oracle databases to Postgres today, specifically in the context of Amazon Relational Database Services. Now, of course, the first thing to talk about is why migrate from Oracle to Postgres. And from what customers have been telling us for the last couple of years, these are some of the reasons that they've given us for why they want to move from Oracle to Postgres. One is they're looking for the simplicity and innovations available with open source databases. And so, they see the pace of innovation and the pace of change with open source database projects moving much faster, and they want to take advantage of that. At the same time, they also see open source platforms as being a lot simpler and easier to use. Another reason customers give us is they see lower costs and no licensing requirements for open source databases, and specifically with Postgres. They see a much different cost footprint as compared with Oracle. A third reason is to reduce uncertainty, just uncertainty in terms of release cycles and commitment to innovation that is customer-centric. The Postgres community, as we'll discuss in the next few slides, has a really good history, a really good track record of being responsive to what their end users ask for and to adding cool new features to the Postgres platform on a very consistent and regular basis. And then the fourth reason is many customers believe that Postgres is the most compatible open source database for Oracle applications to move to. And I'll go into a lot more detail on that in a few slides. And the other question that we want to talk about in this presentation is why migrate databases to the cloud. And again, customers are telling us they want to move their databases to AWS to help reduce costs rather than taking on the CapEx expenditure of purchasing hardware and software for 3 to 5 year timeframes. They'd rather move to a pay-as-you-go model in the cloud. And they also anticipate simplifying their operations. They expect that moving their databases to AWS, they'll be able to have a much simpler operational profile in terms of both sysadmins and database administrators. And they also see opportunities for much more flexibility and just more possibilities. When their databases are in AWS, they see opportunities to integrate with other AWS services and start spinning up a flywheel of innovation for their own applications to help their business go faster. And so I mentioned a couple slides ago that customers are telling us they believe that Postgres is the most compatible target for most of their Oracle workloads, and this slide goes into some of the reasons why. First off, of course, Postgres is open source, but it's an open source project that's been around for more than 20 years. The Postgres database was first made an open source project in 1996. It's not owned by a company, it's owned by a foundation. And the open source license that they chose at the start of open sourcing Postgres is very permissive and makes it very easy for people to fork Postgres and go off and do cool, interesting things with the project or with the technology. And that has resulted in literally dozens, if not more than 100 different forks of Postgres over the years, where a lot of the ideas that people have experimented with in those forks have actually been contributed back to the core project. So the strategy of having a very permissive open source license has paid off for the project, in that all kinds of new features have come out of those forks, which has really been spawned by that permissive license. Along with that, the Postgres project has been very consistent in focusing on high quality of their source code. And so that has resulted in a very stable and very high performance database pretty much almost from the beginning. And so Postgres now has a reputation for very good performance and very good stability, especially for open source databases, but actually even in comparison with commercial databases. The Postgres community has also been focused on features and functionality. And so the SQL dialect it supports is ANSI SQL 2008 compatible, and actually mostly compatible with ANSI SQL 2011. And has some interesting enhancements on top of ANSI SQL standards as well. Postgres from the start has also been object-oriented, which is important to a lot of customers. And then Postgres has really good support for geospatial capabilities, which is becoming more and more important for more applications that have at least an element of IoT, if not being directly IoT focused. So keeping track of where all those devices are out in the real world with geospatial features is becoming more important. Postgres also has really good support for store procedures in multiple languages, including PL/PG/SQL, which is very similar to Oracle's PL/SQL. And this, of course, is one of the reasons that customers identify Postgres as a good migration target because of its strong support for store procedures, because Oracle customers are often very comfortable using lots of PL/SQL for store procedures and triggers, etc. So they find that moving to Postgres isn't as hard as it would be to other databases because of PL/PG/SQL. And so these are some of the reasons that customers give us for why Postgres is a good target for migrating off of Oracle. But these are reasons from customers. In addition to that, we also have data. I'm going to talk about the schema conversion tool a little bit later, but suffice it to say that SCT will look at a source database and give you an assessment of what it will take to migrate that source to a given target. And when you use SCT to estimate what it will take to move an Oracle database to a Postgres database, it gives the highest automatic conversion rates for that target moving from Oracle. Sometimes the conversion rates can be in the mid to high 90s in terms of percentages. So SCT, the data from SCT tells us that Postgres is usually the best target for an Oracle migration. So I want to talk a little bit about why migrating from Oracle to Postgres, specifically in AWS, makes sense. And first off, let's take a look at what the picture looks like for customers who are entirely on premises. When you're running applications and databases on premises, you, the customer, are responsible for all the things in this stack you see on your screen. From the bottom of the stack, which is power, space, and cooling, and networking, and space, and racking and stacking of all the servers and storage and networking equipment, all the way up through all the other activities on this stack, you're responsible for all of them. Now, most of these are what we call undifferentiated heavy lifting, where anyone who runs a data center has to do all these things. And so customers who want to migrate databases and other services to AWS, at the very least, they're going to move some of that stack of activity over to AWS. And so when you move software such as databases into AWS, just running it on our EC2 Elastic Compute Cloud service, then you moved the responsibility for the lower part of that stack off to us. So, at that point, we're now responsible for power, space, and cooling, and racking and stacking, and managing servers, and keeping OSs up to date with security patches and enhancements and upgrades. But you're still responsible for the stuff on the left, including all the database management and configuring high availability and managing scaling and everything else. And so we started a service back in 2009 called RDS, or Relational Database Service, a managed database service. And the goal with RDS is to move almost everything off of the plate of the customer, everything that's boring and repetitive and undifferentiated, and leave the customer to focus on application optimization for their applications that are running on those databases. And this allows customers to have their people pretty much entirely focused on adding value to their business by working with their customers, rather than spending their time on all the stuff on the right-hand side of this slide. Now, as I mentioned, RDS started in 2009, and we started in 2009 initially with RDS for MySQL. So we were initially providing managed MySQL inside of AWS. And then in 2012, we added support for both Oracle and SQL Server. And then in 2013, we added support for Postgres. And now in all four of those cases, customers are using RDS to manage standard database engines from third parties not from AWS. In I think it was 2014, we announced the Aurora project, and Aurora, or Amazon Aurora, is designed to rethink how relational databases are done and re-implement them for the cloud. Now, we started that project with MySQL. We have more recently added Postgres compatibility to the Aurora project. And the goal, as you can see at the highest level, is described on this slide, focusing on performance and availability, and also simplicity and low cost. And just a little more detail on what Aurora looks like. It is reimagining relational databases for the cloud right from the bottom layers of a relational database. And so with the Aurora project, we have focused on the logging and storage and caching layers of the traditional relational database stack and re-implemented those for AWS. So we've implemented a cloud-optimized database-specific storage system called Aurora Storage, which is not general purpose storage. It's optimized specifically for MySQL and Postgres relational database traffic. And that allows us to deliver much higher performance, much higher availability, and much higher durability at a much lower cost, all optimized for AWS. It also is, of course, integrated with other AWS services. You can see some of them listed on the slide, but that's by no means the only list. There's many other services that customers are integrating Aurora with. And it's also part of RDS. So it is a managed database service, just like the other RDS services. Again, the goal is to make it so that it's very easy for customers to do the boring, repetitive stuff automatically, rather than having to have DBAs and sysadmins doing those actions manually. And so, great, we've got all these managed database services, and if you've identified that you want to move some Oracle workloads to Postgres in the cloud, how do you get there? How do I get my data there? How do I migrate my on-premises data? And how to make that so that it's not disruptive to my users. And so, the primary goal of DMS, of Database Migration Service, is to make migrations easier and less intrusive. And we want to make it possible for you to migrate with as low downtime as possible from Oracle into Postgres in AWS. And one of the interesting things with focusing on migration of database migrations is that customers don't just want to do one-time migrations. We initially started off with that focus of making it easy to migrate from A to B, but then customers started asking for ongoing sync, ongoing replication. And they asked for that both between on-premises databases, but also between different engines. And much of this is being driven by customers who want to move from Oracle to Postgres. And so, these are some of the questions that they've been asking us and that we've been designing answers for, including database migration service and schema conversion tool. And so before DMS, migrations, were costly. You often had to use very expensive, license-intensive replication software to move your data. And migrations weren't simple to set up. These tools weren't simple to set up or use. They often required experts to help you use the replication tools. The other option was to take really long downtime and, to migrate in a more manual way. And so customers who wanted to switch engines had to deal with lots of differences in data types and table syntax and store procedures and functions and triggers, and they had to deal with all those differences manually. So with all that in mind, we developed the database migration service. Now we designed it to be simple so that you don't need those experts, those expensive experts to help you get going. You can get it started in less than 10 minutes for a lot of migrations. We also designed it to enable near zero downtime migration. And we designed it to basically be kind of a replication Swiss Army knife, where you can replicate data between on-premises systems, between RDS, between databases running on EC2, and across multiple database engine types. And you can see we've had a lot of success, rather customers have had a lot of success using DMS to migrate databases since we started. And so let's talk about what scenarios it makes sense to use database migration service and schema conversion tool. So DMS and SCT can help you modernize, migrate, and replicate. And by modernize, we mean you can use DMS to help you convert from one engine to another, such as from Oracle to Postgres or Aurora Postgres, and also update the application code associated with those database engines using Schema Conversion Tool, specifically the code conversion features of Schema Conversion Tool. Now, that's modernize. You can also simply use DMS to migrate. You might be looking to move data from point A to point B, and whether that's on-premises to the cloud, or between EC2, a self-managed database on EC2, and RDS, or between engines such as from Oracle to Postgres, or from an on-premise data warehouse to Redshift. DMS can be used for those scenarios. And then the third scenario is replication, where you can leverage the power of continuous data capture, CDC, and keep changes flowing from the source database to the target on an ongoing basis, not just as a one-time migration. And so the real power of this solution becomes apparent when you realize that you can move between engines or between data warehouses, between database engines or between data warehouses, which enables you to move away from expensive commercial databases such as Oracle to cloud-native open source solutions. And we don't believe at AWS we don't believe in vendor lock-in. You can use DMS just as easily to move data out of the cloud as you can to move data into the cloud. Now, data warehouses are kind of a special case. They generally have really large data sets that can't be moved over the internet, over the wire, in a reasonable amount of time. But SCT, Schema Conversion Tool, can now convert the warehouse schema into Redshift, which is actually originally based on Postgres, and extract the data from the source warehouse in a format that Redshift can ingest. Now, Redshift, as I mentioned, is based on Postgres. It's a fully managed petabyte scale data warehouse that makes it simple and cost effective to analyze all your data using your existing business intelligence tools. So these new SCT data extractors from Teradata and Oracle data warehouses make it really easy to migrate those data warehouses into Redshift. Now, you might be saying, hey, I have a huge data warehouse on premises. How am I going to migrate that across, and a public internet connection into an AWS region somewhere? Well, we've actually integrated SCT and DMS now with the Amazon Snowball service, which allows you to take a Snowball device and bring it into your data center, load all your data onto the Snowball device, and then ship it back to us, and we'll, of course, plug it in on our side and make it available to you for import into Redshift. So, we're helping customers address that problem of how do I move really large amounts of data from on-premises into AWS. Now, the net of all this is that DMS and SCT bring a lot of advantages to you and make it a lot easier for you to move your databases from on-premises into the cloud. They help remove those barriers of migrating, especially from one type of database to another. And as you'll see, that they help you do it with near zero downtime while keeping everything encrypted and secure. And out of the box, they're easy to use, but they also have a lot of capabilities if you need to get fancier and more complex in your migrations. They enable database freedom to choose the database platform that you want for given data processing requirements. And they allow you to move to the cloud in steps rather than having to move everything in one big bang. And finally, of course, they're cost effective compared to the license intensive replication tool options that have traditionally been available. So let's get into a little detail on how DMS and SCT work and how they help you do these migrations. So the database migration process really depends upon two steps. Let's say you have that source database of an Oracle database on premises, or an EC2, or even an RDS, and you want to move it to an Aurora database. Well, the first step is to convert the schema, the tables and the views and the the store procedures and triggers, and for that we have schema conversion tool. And then step 2 is to migrate the data. Once you've converted the schema and you have the schema ready in the target database, DMS can then be used to copy all the data from the source database and convert it to the right formats for the target objects, the target schema that you've created with SCT. Now SCT itself, of course, can't always automate everything. In fact, it's rare that you'll see a source database when you're going from, say, Oracle to Postgres. It's rare that you'll be able to migrate 100% of the objects without some manual intervention. But SCT will help you figure out which specific objects need manual intervention, and how much manual work it's going to take. And so SCT, for every migration, you can actually have it generate an assessment report that gives a detailed report of what it will take to migrate from source to target. And so SCT is really useful to help you estimate the amount of work it's going to take and identify these specific steps that you're going to have to work on. Now SCT can also run interactively, and this is an example of an SCT the SCT User Interface. On the left-hand side, it's showing the source schema. On the right-hand side, it's showing the target schema. And in the box in the middle, in the upper part of the screen, it's showing the detailed exceptions, and not just exceptions, just diagnostic messages about each object that is looked at, and what work needs to be done, or just kind of telling you, hey, this object can be converted automatically. This one you need to take a closer look at because of this particular data type, for example, so on and so forth. The two smaller boxes in the middle of the bottom of the screen are some source PL SQL and some target store procedure code. So you can even actually manually edit the code kind of in line in the SCT User Interface. So in addition to giving you that assessment report, you can also use SCT as an interactive tool. Now let's look at how it is that DMS can enable zero downtime migration. Now let's say you have your database running on premises and your users are connected to that on-premises database, and you want to move that database into AWS across the internet. Well, the first thing you're going to do is start a replication instance, an instance of DMS running in AWS. And then the next step is to connect that DMS instance to the source database on premises and to the currently empty target database. And then you can actually go into DMS and select which tables or which schemas or which databases. You don't have to replicate everything in the source database, so you can choose. So you'll use DMS to go select which objects to replicate, and then you let DMS do the replication. It will create the tables, it'll load the data, and then it will keep them in sync. And it will keep them in sync indefinitely until you're ready to switch your applications over to the target database at your convenience. So the only downtime you will see in this scenario is the downtime it takes to disconnect your application users from the source database and reconnect them to the target. So it's not zero downtime, but it's almost zero downtime, and it's also completely under your control when that downtime happens. Now I mentioned that you can actually choose which tables, and that also implies that the load is table by table. And so one of the things you can do with DMS is actually load each table in parallel. If you want your loads to go faster and your large portions of your data are spread across multiple tables, you can have each DMS process loading a separate table in parallel. You can also pause the replication before it's completed, and when you restart it, it will continue from where it was left off, or from where it was stopped. So, DMS has lots of intelligence. It's not just a blind, simple replication tool. It can do lots of sophisticated things. Now, if you want to use DMS for change data capture, where it's going to do ongoing replication from the source to the target, depending on the source, you may have to enable certain features. For example, with Oracle database, you need to enable supplemental logging. With MySQL, you need to enable row-level bin logging. With SQL Server, you need to enable bulk logging or full recovery. So it doesn't use an agent on the source. It uses the recovery logs of each of those database technologies. And it uses those log records to basically figure out what changes are being made to the source database. It converts them to the right format to be applied to the target database. So it should be pretty obvious now that you can use DMS to move data from A to B, and many customers have used DMS to do just that. But some customers have been pretty ingenious with DMS, and they've actually done fan-in. They've fanned in or consolidated systems. So DMS will put data where you ask it to, so if you want to merge data from a number of legacy systems into a single target repository, DMS can help with that. And remember, DMS can just as easily move data between like databases and unlike databases. So you can take information from a number of different platforms and consolidate it into a single cloud database. In addition to fanning in or consolidating, we've also had a customer who has taken their database and fanned out different portions to different targets. For example, from their ERP system, they replicated their customer list out to the CRM system. And they also take some of the general ledger transactions and funnel them over to a BI system. We've also had a customer who, for legacy reasons, used a single database for 3 different applications. With DMS, you can split this information out to different databases. One could be Postgres, one could be SQL Server, one could be Aurora. And in addition to taking data to different locations, some organizations might have many years of historical data, and maybe they want to do filtering during the migration so that only newer information is kept in the target. And filtering can be done on any field in that source database, not just date fields. So, you can do pretty complex filtering if you have criteria that help you identify which rows can safely be left behind. And just in case it wasn't abundantly clear, DMS can move your data from pretty much anywhere to pretty much anywhere, sort of like a courier company for the cloud. And that doesn't apply just to standard relational databases, but also to data warehouses. And we continue to add new connectors, not just for data warehouses, but for other data sources and targets. So, this is not the end of the innovations we'll be adding to DMS and SCT. All right, so let's take a quick look at what some of our customers have done to migrate from on-premises databases, especially commercial databases, into AWS. And so one example is Trimble. Now Trimble, has been running Oracle in its own private data centers, and they have used SCT and DMS to migrate to RDS Postgres, to our managed Postgres service. And they actually used ongoing replication with DMS to keep their databases in sync until they were ready to do cutover. And so, this helped them by improving reliability in the cloud. It helped them, of course, with tremendous savings on Oracle licensing costs. And right up front, they used the SCT assessment reports to understand the scope of the migrations, to understand the amount of work it was going to take and to plan accordingly. Another example is Expedia, which migrated from RDS MySQL to Amazon Aurora. And again, they used DMS with CDC, ongoing replication, just like Trimble did, to migrate their data. And Aurora specifically allows them to handle larger data than standard RDS MySQL, more data storage. And so, they have regulatory requirements that results in them having to store 120 terabytes of data for at least 2 years. And Aurora is much better suited to handle that, and DMS has helped them get there. This also actually helped them improve performance and reduce costs. And then Flipboard used DMS to migrate from RDS MySQL on our old EC2 classic environment to our newer VPC environments. And they really couldn't afford downtime. It ran a customer-facing application for them. And they basically, reduced their downtime for these migrations to less than 5 minutes by using CDC as part of DMS. And so far, they've migrated 70 of their RDS instances pretty much seamlessly. And then there's Haadi, which has 35 million members on its site, built a lot of applications that are interdependent and that also have really high I/O throughput requirements. And they wanted to migrate from a legacy cloud service into AWS. And so they had a combination of migrating to MySQL and to Aurora. And DMS reduced the amount of time required to migrate their databases by almost half. And they saw more than 50% cost savings by moving into Aurora, which gives higher performance for a given size instance. So the price performance is more effective for them. So we've been talking about moving data and what it will take to move from an Oracle database to a Postgres target in AWS, especially using DMS and SCT. But it really takes more than just moving data and converting schemas and moving data. And so to help customers with migrations, we work closely with our AWS database migration partners. Now, these partners are experts in helping customers migrate from on-premises to RDS, or from EC2 to RDS, and from commercial database engines, including Oracle and SQL Server, to open source engines such as MySQL and MariaDB and Postgres, and of course the Aurora versions of MySQL and Postgres as well. It's key for customers looking at any significant migrations to talk to partners who have done this before, because there's always a lot of work to move the application infrastructure that's wrapped around your core databases and applications. And we have a number of other consulting partners within the Amazon Partner Network who are very familiar with these kinds of migrations and familiar with the services that customers use for the migrations. And so it's important to make sure you reach out to a consulting partner who knows what they're doing, because they'll be able to give you very good advice on what it will really take to migrate a given application from Oracle to RDS Postgres or Aurora Postgres. Thank you for your time. Love to spend a few minutes taking some questions and helping answer your questions about your environments and what it will take to help you move into the cloud.